welcome to BHARGAV SUBS. So in today's class, let us discuss the concept regarding Ampere's equation. Right, Ampere's equation is nothing but like it says like a relation between magnetic field and the current passing through the any loop or any circuit. Right, so like due to the change in electric field, there was a magnetic field created. Like if you change the electric field, if you change rate of change of electric field, there will be a production of like magnetic field in the loop, like in which the current was passing. So due to that current, there was a creation of current density, right, or current density, charge density, so like so many. So like to give the Ampere's equation, I am considering a loop in which the current was passing. So this was a loop in which the current was passing. So the current density created was J, and the surface I took here was ds, and I am considering a small element dl in like it was a loop, no? So I have to integrate for whole loop, right? I have to integrate for like surface integral. I have to integrate for surface integral. So I am considering a small element dl, so in which like it was created magnetic field B, right? So magnetic field B was magnetic field. So J was current density, so in which like the current passing. So I have to show the Ampere's equation, no? Right, Ampere equation. So to show that Ampere's equation, now I want to first integrate like magnetic field with dl, right? So surface integral, this was surface integral magnetic field dot dl is equal to what I will get, mu naught into like there was a current enclosed in that circuit. Due to that current only that magnetic field was created, no? So mu naught into I enclosed means we are considering a loop. So what is the current present in that loop? It was known as current enclosed in that loop. So in surface integral B dot dl is equal to mu naught into I. It was like first it was the one of the equation. Again I am applying same like surface integral for cross product. Okay, divergence like I am taking curl of magnetic field. If I take curl of magnetic field, see, if I take curl for the surface ds, like I have total surface ds, no? I am applying curl means del cross B ds. So I am applying curl to magnetic field. What I will get, like there was a current density, no? So I will get mu naught closed integral surface integral mu naught like surface integral J dot ds. Now I am taking this equation to left hand side. So I will get surface integral del cross B ds minus mu naught surface integral J dot ds is equal to 0. Now I am taking common like ds and surface integral. So surface integral del cross B minus mu naught J ds is equal to 0. So what I will get, like ds is not equal to 0 here, because like it was like some area we are considering. So if you consider a loop, so it will have some surface area. It was not equal to 0 because you are not considering a point, you are considering a loop. So it must have some surface, so it is not equal to 0. If it is not equal to 0, you can make it transfer to right hand side. 0 by anything, 0 by ds is equal to 0. So I will get surface integral del cross B minus mu naught J is equal to 0. Like I took surface integral to right hand, like ds to right hand, no? So no need to apply integral, right? So del cross B is equal to mu naught J, right? Again I have to apply divergence on both sides. To this equation I am applying this was let us consider as first equation. So for first equation I am applying divergence on both sides. So if I apply divergence on both sides, divergence dot curl is equal to divergence dot mu naught J. So I know divergence of any curl of any field is equal to 0. of any field, like if you take magnetic field or if you take electric field, whatever it may be, divergence of any curl of divergence of curl of any field is equal to 0, right? So I can write this as 0 is like divergence cross B is equal to 0. Okay, so wait, you can confuse, you can substitute here directly 0 is equal to divergence of mu naught J, since divergence dot of any curl is equal to 0. So I got divergence dot mu naught J is equal to 0. So like finally I got mu naught J is equal to 0, means if you substitute here, what you will get, like you got divergence of mu naught J is 0. So it means what? There is no current density, it was saying, but we have current density, right? So like it was saying the magnetic field which was created is not only due to the current which was flowing through it, but also there is some conduction current in it, in which like it changes with respect to time. So you have to consider time varying function of electric field also, right? So you have to consider not only the electric field due to the current present in it, but also the current which was produced by electric field with time varying. So there is some term missing, like you got this as 0. So like after applying divergence I got 0. So curl of B is, like I applied divergence, after applying divergence I got 0. Okay, so if I apply, so the curl of B is mu naught J plus some term is missing here. Okay, some terms are missing. So I can say that the electric field which was like passing through it is not only the statistical electric field does not produce current, right? For example, if I consider a capacitor, so the current was passing here, but here it was like block the current, it is blocking the current here, because like if there is a dielectric here, it was blocking the current, right? So here you are not considering current, but there is a current in the external circuit now. The external circuit, the current was passing, so you have to consider the external circuit also. It was that electric field varying with the time, right? You must have to consider the current which was passing in the circuit, not only the electric field created here. You can write here what is the energy of this capacitor. E is equal to half CV square. So Q is equal to CV, no? So E is equal to, I can write in terms of CV, and also I can write this equation in terms of Q. If I want to write C is equal to Q by V. So Q by V into V square, which is half QV. So QV I got in terms of CV, QV and CV, like CV, QV, CV, like half into Q into QC. I can write in terms of QC. So what is the C? Q by Q into what you can write V, Q by C, Q by C whole square. Okay, is equal to half into C into Q square by C square, which is half Q square by C, right? So I got half Q square by C as one equation, energy of capacitor in terms of QV, energy of in terms of CV. So I got like these are the energies of the capacitor. So like casual I told, so these are the energies. So if you draw a graph while time was moving, like it was like time was going on, the electric current was going on decreases in the capacitor, right? So I can say the electric current is not only due to the statistical electric field. So I can write here So electric field which was produced. So statistical electric field, statistical electric field does not produce electric current. Electric current means if you taking the capacitor here, I not equal to 0, here like here J is equal to 0, like current density is equal to 0, because like you are not considering the external circuit, right, because you got here mu naught J is equal to 0 divergence. So there was some term missing. What is the term missing? Because you have to consider the current which was varying, current which was created by the electric field with time varying. So you have to consider here mu naught dou E by dou T. So this term also you have to consider, like the electric field with which like varying with time, right. So it is also like created due to the magnetic field, change in magnetic field. So curl of B is equal to mu naught J net, like there was a some current density, like total current density. So del cross B is equal to mu naught J free. So the current density with which like electric field was created, okay, like electric field was created with time varying. So you can write J displacement. This is known as like displacement current density. So this was the final equation of the, like after Maxwell came, he was corrected, like there was some created. Actually Ampere gave the equation of Ampere equation was like actually this equation up to here only, but after Maxwell came, he corrected, there was some current with which electric field was created. So you have to consider the function with which it was changing with time. So the electric field was changing with time, so you have to consider that electric field also. So Maxwell extended the Ampere's equation to this, right. So actually like final Ampere equation was like del cross B is equal to mu naught J, right. So there was a current density created due to the displacement current also. So this was the Ampere equation derivation, right. Thank you.